Section 6.2 of your textbook covers the topic of multiplying and dividing rational expressions. The key idea to keep in mind is that the processes for performing these operations on rational expressions are analogous to those for rational numbers. The reason for this is the similarity between the definition of a rational expression and the definition of a rational number. When multiplying two rational numbers written in fraction form, a over b times c over d, we simply multiply the numerators and multiply the denominators. This same process can be used to multiply rational expressions. When dividing two rational numbers written in fraction form, a over b divided by c over d, we first rewrite as an equivalent problem involving multiplication by the reciprocal of the divisor, a over b times d over c. The same process can be used when dividing rational expressions. Let's do some examples. In each case, we will perform the operations, simplify, and list any restrictions on the problem. In problem number 1, we're multiplying two rational expressions. In order to simplify and identify restrictions, it's helpful to have all the polynomials written in factored form. So let's begin by factoring the numerator of the first expression as the quantity x plus 5 times the quantity x plus 1, and then factoring the difference of two squares pattern in the denominator as the quantity x plus 2 times the quantity x minus 2. We're multiplying by the quantity x minus 2 over the quantity x plus 1. As when multiplying with rational numbers, we can simplify common factors before multiplying. We can remove the common factor x plus 1 from the numerator and denominator, and also the common factor x minus 2. This leads to our answer, the quantity x plus 5 over the quantity x plus 2. In order to identify the restrictions, we need to look back at the original rational expressions prior to multiplication, and we see that there are three values of x that would make one or the other of the denominators equal to 0. So the restrictions are that x cannot equal positive negative 2 and negative 1. Let's look at the second problem involving division. Once again, it's helpful to have all our polynomials in factored form. In the first rational expression, the numerator, the three terms have a common factor of x. And then we're left with a perfect square trinomial. So we can factor it as the binomial x minus 4 squared. In the divisor, the numerator has the greatest common factor of both terms, x squared. And the denominator, the trinomial, can be factored as the quantity x plus 5 times the quantity x minus 2. Since we're dividing by that expression, we can multiply by its reciprocal. Then we can remove common factors. There's a factor of x in the numerator and two such factors in the denominator. There's two factors of x minus 4 in the numerator and 1 in the denominator. And then there's also a common factor of x plus 5. This leads to our final answer, the quantity x minus 4 times the quantity x minus 2 over x. Now we need to be careful when identifying restrictions if division is involved, because in addition to the fact that the two denominators of our original rational expressions cannot equal 0, we also have to make sure that the numerator of our divisor is not equal to 0. Because if that were equal to 0, then we would be dividing the first rational expression by 0, which would result in an expression that's either undefined or indeterminate. So looking at the factored forms of those three polynomials, we can identify four restrictions on this problem. X cannot equal negative 5, 0, 2, and 4. Let's do two more examples. this case, the problems are slightly more complicated, involving several variables. We won't worry about restrictions, but we will perform the operations and simplify our answers. Problem number 1, we have division by the square of a trinomial. So we can rewrite as multiplication by the reciprocal of that expression. Now let's write all of our polynomials in factored form. Note that by the law of exponents, raising a product to a power, we can identify two binomials that are both being squared in the denominator of our second expression. So how do we simplify? We look for common factors. There's a factor of 3x plus y in the numerator and 2 factors in the denominator. There's a factor of x minus y in both the numerator and denominator. We can write our final answer then as 1 over the quantity x plus y cubed. Let's look at example number 2. We have 3 rational expressions here. Both multiplication and division are involved. Let's write each fraction in factored form. The numerator of the first rational expression has a difference of 2 squares pattern. The denominator has a greatest common factor of all 3 terms, of c. Then we can factor further as well. Again, the numerator has another difference of 2 squares. And the denominator contains a perfect square trinomial. Our second rational expression is already in factored form because a sum of squares cannot be factored. Our third rational expression, we can factor the perfect square trinomial in the numerator. Then find the reciprocal and multiply. Finally, let's simplify, removing all common factors. Note that there are 2 factors of a plus 3 in both the numerator and the denominator. And there are 2 factors of a minus 3b in both the numerator and denominator. So our final answer is the quantity a minus 3b over c.